Okay, so let's change gears here a little bit and talk about something called a difference quotient. A difference quotient is an application of our functions in that in our function what we're doing is we're substituting in a value and we're going to take a difference in the value of f of x plus h minus f of x over h, as long as h is not equal to 0, and simplify this quotient. Now, let me first of all, let's just go through the mathematics here and just determine what all of this means. When we say f of x plus h, remember that the function notation is such that whatever value of x you substitute in for x, so if I have 2x squared plus 5x minus 3, it means that anywhere you see x, you're going to substitute in that value to determine the value of the y, to determine the value of the function. So it's very much a case of f of whatever's in the parentheses is equal to 2 times whatever's in that parentheses squared plus 5 times whatever's in that parentheses minus 3, right? Certainly we could find f of 1 that way, or f of 0, or f of any other number. So what would f of the quantity x plus h possibly mean? Well, in this case, it means that we're going to substitute in the quantity x plus h for x anywhere we see it within the function. And then we're going to simplify this piece of the function. So when you see the difference quotient, f of the quantity x plus h minus f of x all divided by h, we're actually going to replace f of x with the function. And we're actually going to replace f of x plus h with its equivalent. So we're actually going to be taking 2 times the quantity x plus h squared plus 5 times x plus h minus 3, and subtract from that the original function, which is 2x squared plus 5x minus 3. All divided by h. And we're going to simplify and evaluate this expression. So, we need to get ready. This is a bit of expanding that we're going to have to do right here in order to evaluate this, but that's okay. We can handle it. We know what happens with x plus h squared, for example. This is the same thing as saying 2 times the quantity x plus h times x plus h plus, I'm going to distribute this 5 here into that quantity 5x plus 5h, all minus 3. When I multiply right here in this first term, I will have 2 times the quantity x squared plus x plus h plus x plus h. That's 2 times x plus h. Don't forget that's one of those special products that we use. Plus h squared plus 5x plus 5h minus 3. And so when distributed, this becomes 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 3. So this is the quantity that gets replaced here in our difference quotient. And we're going to have 2x squared plus 4 times x times h plus 2h squared plus 5x plus 5h minus 3, that's our first quantity here in these brackets, minus the quantity I'm going to distribute now, 2x squared minus 5x plus 3, all divided by h. Well, these parentheses that come in front or around our first quantity can just simply be dropped. We've got a plus symbol in front of them. Well, actually, we have no symbol in front of them, so we treat that as a positive. So we've got the quantity 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 3 minus 2x squared minus 5x plus 3, all divided by h. And you look at that big long string of terms, and you might have noticed that we do have some common terms that can be eliminated. 2x squared and negative 2x squared, for example, are the same term. They just subtract out. 5x minus 5x goes away, and minus 3 plus 3 goes away, and we're left with a much shorter expression now that looks like 4xh plus 2h squared plus 5h, all divided by h. And you'll notice that in the numerator, all the terms have a factor of h that can be factored out by our distributive property. So we're left with h times 4x plus 2h plus 5, all divided by h. Now, provided that h is not equal to 0, this expression becomes 4x plus 2h plus 5. Again, provided that h is not equal to 0. Now, you might be asking yourself, well, what does this actually mean? The book has a wonderful illustration of a function just like this one and what we're actually doing. But in essence, what we've just worked out has been the equation of a tangent line to a parabola. And I'll exaggerate. Let's say this is what my function f of x equals 2x squared plus 5x minus 3 looks like. And what this quantity actually represents for us is the following. At some point x, we get a y value that goes along with it. So here's the point x, f of x. And at some other point a little bit further down the line, x plus h, that is a point h away from the original function x, we get another y point here that we would designate as x plus h, f of x plus h, and what we've just witnessed was the slope of a line that passes through the curve in these 2 points. The slope is found as the change in y values over the change in x values, and if we were actually work out what this looks like, f of x plus h, the y value at the point x plus h, minus f of x is our change in y values. Our change in x values is the quantity x plus h minus x, and if we actually work that through, lo and behold, we have what's called the difference quotient. And the formula that we just worked out above, at least for this particular function, f of x equals 2x squared plus 5x minus 3, is the formula for the slope of a line passing through any point x at some point h away from that point. All right, more to come in the next videos.